morning, everyone. We're doing another science paper that I made up on the spot. Actually, I came up with this on the car ride to my dad's house to go visit my cat. Anyway, so let's talk about entanglement states. Oh, off to a great start here, people. Hold on a second. Entanglement states of structured nuclei. All right, so let's see what's the date again. I'll say this is 10/4. Oops, 10/4/25. Toby Martin. All right, so what's the deal with structured nuclei? It's like I was thinking about the structure of a tritium, which is a proton and two neutrons like this. I'll just say that this one is the shade is the proton. These are the two neutrons. We have a rigid structure, which is deterministic in its arrangement, which is good, and then but also has a collapsible center at the void, where it's like, okay, if we somehow manage to fuse all these together, I'm not sure how exactly that'd go about doing that, but it's like, all right, if that happens, maybe we have a Doc Ock Spider-Man 2 by Sony Pictures scenario. So let's just imagine this tritium here. This is H3. It's like this is tritium. So let's just imagine this as a single side, because I was thinking about the next most complicated or next advanced structured nuclei that could have chiral character, which is something with a virtual center and then 4 functional groups, or 4 at least separate connectivity regions that are all unique. And so what I thought of after this is like, what if we had 3 of them as tritium and with proton in each of its different positions, and then the last one is just all neutrons? And what do you get when that happens? We have 3 sides that are like this, plus 2 neutrons, so we have 6 neutrons. 6 neutrons and plus 3 at the bottom, so that would be let's see, lithium 9. So that would look something like this. So we're having a virtual center. It kind of resembles chiral chemistry, and this is the hard part. Is like we have chiral chemistry now, but then when they have racemic formations, we get entanglement states. And so it's like, all right, what are the entanglement states of structured nuclei? That is a really good question. I wonder if it has something to do with the energy transfer or mass effect. It's like energy and mass are often the same. So it's like, am I really just discovering the real life version of the Mass Effect video games? Anyways, working on that. I'll let you know how it goes. Let's see. So I'm going to draw this tetrahedron and let it be kind of resembling that of a chiral carbon. Usually we do something like here, right? But let's just say that the top face of this is going to have a proton here. This one's dark, and this one's neutron. This one's going to be like this. This one's over here, and then this one over here is going to be the top. Okay, I want to mess that up. So like that, and then this last one would just be all 3 neutrons like that. And so if you actually put this together, it might resemble, let's see, the Pathfinder, I think. I want to see if it's like the balloon airbag thing that goes on the outside of Mars landers. I was trying to figure out if this one, this one I think resembles it. I was trying to find one with the thing deployed, but it has these planes that deploy airbags to help that land. But anyways, so we have, this one has all neutrons. This is going to have 1 proton here. This one has 1 proton here, and this proton over here. And then this is kind of arranged around a virtual center with virtual vertices. And so if we had these forming at the same time, and this one would be lithium 9. And so it's like, what can we do with all this these structured nuclei if we could somehow have an entanglement state where they are connected together, or like at least collapsing at the same time, or not replicatable, or some other magical godlike properties, like usually what happens when we discover a new force of nature. It's like we are a covalent species, so we're having a real time trying to figure out what to do with it. But if we have any experts, I hope they come forward wherever they happen to be, wherever and whoever they are. But they also could have been like, dude, if this guy discovers this shit too soon, we're going to be in a lot of trouble. But I don't know, I just thought of it in the car. Who knows what's going to happen next? I figured is check out the periodic table and figure out what other elements that might be achieved if we want to have 3 unique positions and then one as nothing. And so that allows us to do, what if one is just like this one's like this, and then add, well, actually I think we just start at let's do 1 proton at a time. Let's leave these neutrons alone. So that would bring us up to, so beryllium. Oh yeah, exactly. So this would be beryllium 9. So we might not be able to do beryllium 9, and then let's see, if we added 1 more, it would therefore be boron 9. Oops. And it's like, and then if you add, it's like another one over here, we could also get up to carbon 9. Is that even a thing? Is it structured with a structured nuclei? It's like carbon 9 would be interesting. What is the right number of neutrons? Right, 1, 2, or carbons? second. 1, 2, 3, plus 6. Oh, you have to add all the other things together. So I just did. This is all 12. It's for all atomic weights, right? So this is supposed to be lithium 12. Lithium 12, beryllium 12, and then carbon 12. Whoops. Anyways, it's good that we check in on this stuff as we go along. But then suppose we start adding more to this last functional group, you could probably get as many as, I guess we still have to have voids at, anyways, anything beyond a carbon, maybe nitrogen. I'd rather run a simulation before I explain all this stuff, or at least some sort of computational model. But yeah, supposing we could have structured nuclei that resemble kind of these like tetrahedrons, but with like little balls on it like this. It's like if that were the case, and we were able to collapse them in such a way that they would have fusion, that we could have something in the center. Maybe that could be used for energy production, or maybe this would just be useful for listening for vibrations and things that are made out of the aforementioned materials. But who knows? It's like this is literally a big question. Like we have no idea what to do with this because we're a covalent species. But I'm pretty sure it would be arranged something like this, and then we'd start with like lithium 12 based on a couple structures made of minor structures. So this is the simplest structure. This is like an advanced structure with substructures in it. Probably starting with tritium. Anyways, this has been Toby Martin for a quick talk on entanglement states and structured nuclei.